All right, today we're going to do section 7.4, at least the first part of it. And what we're taking a look at in this section is percents or percentages. And the first definition is exactly that word, percent. So this actually comes from the Latin word that means per hundred, as in our cent, right? A penny. It's worth 1/100th of a dollar. So when we write down N%, we mean N out of 100. The percents are interesting because there are some contexts where the value of the percent that you say can be more than 100. And there are contexts where the value of the percent that you say it's not possible to be more than 100, right? Like when somebody says, I'm 110% sure, ... It's a hyperbole, right? We don't really mean 110%. That's one of those cases where you can't be more than 100%. But the cost of eggs can go up more than 100%, and they have very recently. If you haven't bought eggs lately, I just let you know they're crazy expensive right now. We did some baking this weekend, and I was like, $5.50 for a dozen? Are you kidding me? Okay, so percentages are a little bit of a funny thing because it depends on the context as to what kinds of numbers make sense. We're going to take a look at how we adjust between or change between numbers and percents. And there's more than one method. And sometimes there's a natural option that's easier, and sometimes it's kind of just whatever you prefer. So I'd like to show you the three methods. So the first method that we're going to take a look at is, we're going to start with this number 7.9, is that you write the number as a fraction with the denominator 100. So in a very real sense, this number is 7.9 out of 1 to start with. And to change it into a percent, you make it as a number out of 100. So kind of using what we did back in section, or in chapter 6, if you multiply the bottom and the top by 100, like this, then that 7.9 becomes 790 out of 100. And being out of 100 is exactly what this definition says that a percent means. If the number is written over 100, that is its percent form, 790%. So yeah, it's a big percentage, but in some contexts, we can talk about a percentage that actually looks like that, and it's totally appropriate. Okay, so that's method one. Method two is to use a proportion. Now, again, not all these methods are equally good for all things. So you might look at this and say, that's just silly. Why would you do it there? And that may be a valid point. But let me show you how it works. So if you're using a proportion, what you're setting this up as is 7.9 out of 1, just like on the previous slide. And then it's some number n out of 100. I'm looking for that number n. That's the goal. So I'm setting it up as an equation to try to find the missing piece. And you're going to cross multiply, right? So if you cross multiply, sure enough, that 7.9 then gets multiplied by the 100 and the 1n or n, and I have the 790 for 790%. This method tends to work really nicely when you're doing fractions. So sometimes people think that in order to go from a fraction to a percent, I have to go through the decimal stage, and you don't actually. If you use proportions, you can go straight there. So they do actually, this method actually works really nicely for that, and we'll see an example. The third method is probably the one that you know and love the best, and it simply involves moving decimal places. So when you have a decimal, this method works really well. So you're starting with the number 7.9 and you're moving the decimal 2 to the right. So moving it 1 to the right gives me 79. I've got to move it a second place to the right. And so that missing, placeholder right here is the number 0. And I have 790%. So moving decimal places is a very convenient way to change numbers into percents when you have decimals. It doesn't work very well at all if you've got a fraction. All right, so we're going to do a couple of examples that are not 7.9, something different, and see how these work. And I'm going to kind of push into not doing the moving the decimal just because I want to give you a feel for how the other two work, because I think you're probably most familiar with that one. The first one we're going to do is 42.6. And I'm going to go with method one to do this, not because it's like my favorite or anything, but just because I want you to see it. So if you have 42.6 and it's over 1, and you're multiplying the top and the bottom by the number 100, then as you take 42.6 and multiply by 100, you get 4,260 over 100. And then by definition, this means 4,260%. That is a big percentage. B is that fraction one that I alluded to before, right? That we were going to see one like this. Methods 1 and 3 really do not work very well for this value, unless you want to turn it into a decimal first, in which case you're doing 2 steps, right? You're doing an extra layer. It's not impossible, it's just an extra layer of steps. So I'd like to take a look at that proportional setup because it works really nice when you have a fraction. So we're setting it up as n, over 100, and then we're cross multiplying. So I've noticed on more than one paper coming in from the test redos, specifically the phrase cross multiplying being used a little bit incorrectly. Cross multiplying is something you do across equal signs, okay? So when you're combining fractions with addition or subtraction, that's not called cross multiplying. This, what we're doing right here, is called cross multiplying. So we are multiplying across the equal sign, okay? So as we do this, we're going to multiply the 8 times 100, so that's 800. And the 3 times the n is 3n. Then what do?
Divide 3.
Yep, divide by 3. And for what we're doing in this section, specifically with the percents, right? If you want to grab a calculator, we'll go with that, okay, instead of drawing out all the division for this particular one. So somebody would like to grab your calculator. What is 800 divided by 3? I said grab a calculator and everybody's not, and I'm not really sure what to do about this. But we're getting closer. Okay, so Lainey says 266.6, and I think the 6 is repeating. Is that right, Lainey? Okay, so this would be one way of writing this, and it's probably the one that you would go with. I do want to show you one other method or way of writing the answer, just because if you see it somewhere, I don't want you to think that it's somehow different. It just looks a little different. You could see the 266 written, and then the 0.6 repeating at the end written as its fractional version, 2/3. It's a little weird to write it that way, but it's not wrong. It's keeping you from having a repeating bar, like a fraction or a decimal repeating bar in there, which is sometimes a preferable option. So just in case you see it, I don't have a preference between these two, but you might see that written somewhere and want to know that. Okay, so this is just sort of the nuts and bolts of moving numbers into percentages, okay? We're going to go the other direction now, okay? So now what we're going to do is we're going to take a percent and turn it back into some other number, okay? Into a number. So the first method is to divide the number by 100. So we'll make up an example real quick just to put in here. Let's say you had 42%. Then this means 42 out of 100. By definition, that's what it means. And then you can literally divide the number by 42. Divide the number 42 by 100 is what I meant to say. So the 100 goes into 42 0 times, but it goes into 424 times for a 400. And then it goes in 2 times to give me the 200 here. And we would have the decimal as 0.42. You can put the 0 in front or leave it off. Either way is not a big deal. So dividing the number by 100. Method number 2, again, is probably the one that you're most used to. And so this one actually has you take the decimal, if there is one, and move it 2 decimal places or 2 places to the left. We'll use the same 42 just because actually, yeah. So in this one, there isn't actually a decimal, right? It's 42%. And so it means 42 is a whole number. So by default, that means the decimal place, if you will, comes after the 2. And then if you're taking that decimal and you're moving it 2 to the left, you will have a decimal point, and then you'll have a 4-2 behind the decimal. Okay, right? Okay, let's try a couple of this method or this strategy now, or this direction is a better word, direction. We're taking some percents and we're turning them into decimals. Now, that's kind of one of those ones that I told you they look a little weird, right? 4.5%. If you don't like 4.5%, can you think of how you would write it with a decimal? Yeah, so feel free to rewrite it in a form that you like a little bit better. This one's a little bit more friendly. Let's actually take this one and let's move the decimal point, okay? So method number 2, and then I'll do the other one as method number 1. So if I'm moving the decimal point, we actually can see it in this particular one, right? It's right here between the 4 and the 5. So moving it 1 to the left, we'll put it in front of the 4. And then I need to move it one more time, and there will be a 0 in that placeholder. Okay? So we have a decimal point, and then we have the 0, 4, 5. Again, feel free to put a 0 in front of the decimal point if you want it there, but it's also okay if you leave it off. So I think that I probably would have viewed this idea of just moving decimal points as a very simple strategy that students don't really struggle with. And then I have a child in my home who really struggles with moving decimal points. Like really. And I think one of the biggest things is that her handwriting's not super neat, and she tends to write a little bit on the small side. So moving things around is in scientific notation, which we'll talk about later. I mean, it's been a struggle for that girl. So just because something seems like it should be pretty straightforward, don't always assume that the students you're working with think that it is that way as well. You sometimes get surprised by some things. All right, this next one, 125. So we have 125%, and we're going to actually write that as its form. So this is method number 1 that I mentioned, as over 100. So 125 over 100. And then we will write it out so that we can see it. So 125 has the number 100 going in one time. And then there's a decimal point after that. So then I have 25 remaining. And I'll bring my 0 down. So how many times will 100 go into 250? 2 times, and that's 200 with a remainder of 50. And then I'll bring my 0 down. And then 100 will go into 500 5 times, giving me 500 and a remainder of 0 to stop. And my decimal value or my number value is 1 25 hundredths.
We're ready to answer. Do we still have to put the percent sign at the end?
Ooh, that's a good question. Okay, so the answer is no. The percent began at the beginning because it's out of per 100. But when we actually divide it by 100 or when we move the decimal point, either way, we've not got a number that's any longer divided by 100. So there's no percent sign at the end. Yep. Good question. Okay, so we see percents used all the time. If you've ever gone shopping, virtually or in person, it doesn't even really matter, using things that are listed as percents, a percent off, a percent sale, things like that. So there's actually 3 different types of applications that percents can take. You've seen some of them probably more than others, but I bet you've seen all 3 of them. So let's take a look at the 3 types. They sound a little funny when they're written out like this, so I'll give you an example of a phrase that might be used where it's applied. So the first one is to find a percent of a number. So you do this every time you calculate your grade. You find your percentage, right? The number of points that you have earned out of the number of points possible, and then we turn it into something out of 100, right? That's what's happening here. So an example of this, and I'll just write some phrasing so you can see, is something like this. I was explaining number 2. I take it back. Well, let me write in number 2 since that's the one I was explaining. Finding a percent of one number is of another one. So what is 12? What percent is, get the word there, I'm sorry. 12 out of 48. Okay, so 48, look, this is what you would do if you were actually looking at this past test that we did. It was out of 48 points, and if you wanted to know what's my score if I don't do any redos and it started out as a 12, you'd take 12 divided by 48, that'd be your percent. Okay, don't do that. That's not helpful because you got redos, but that's the idea. Okay, let's go back up to number 1 since I skipped it. I'm so sorry. This one says finding a percent of a number. Okay, So finding a percent of a number is often a way to figure out like how much money you're saving on something, right? So like if it's a 15% off sale, how much money are you saving on that blouse that you're trying to buy or whatever? So something like this, what is 15% of $32? Right? How much did I save? And the last one is finding a number when a percent of that number is known. So let me write down my example and then I'll explain it a little bit. 13 is 45% of what number? So what this does is this tells you kind of like the original price that something was, right? What did you actually pay at the register? You saw the percentage off sign. Well, what was the tag originally on that item? Okay. What was the original price? What was the original amount? All right, so we're going to do 3 examples. And then I think that's where we'll pause. I think that's a good stop spot. We'll see, but I think so. So what we're going to be doing is we're going to take a look at an example. Some of them are direct applications of these, and some of them have sort of a little bit of a variance to them that I want to show you. And then I want you to also be thinking of, and we'll actually start with the note part, which type of question is this? There's one of each, right? So I've got an example of each one. So here's our first one. What is the sale price of a softball if the regular price is $6.80 and there's a 25% discount? So read through 1, 2, and 3 above. Which type of problem is this going to be?
Number 1.
Yeah, Kiki's right. It's number 1. This example is number 1. They give you a percentage, so it's definitely not number 2 because number 2 finds a percentage. And number 1 finds the new price of something typically, whereas number 3 finds the original price of something typically. There is a little bit of a question about this one that you have to be a little careful on though, because it says, what is the sale price? It tells you the regular price is $6.80, and then it tells you there's a 25% discount. Okay, so be careful. We're going to do it one way, and then we're going to pause for a moment and examine, is there another way we could do it? Because there's 2 completely different ways of doing this problem, and it really just depends on how you think about it from the beginning. You just need to be careful at the end as well. So these problems are always set up, the way we're going to do them, as proportions. And I know that some of you were not super big fans of proportions back in 6.4. That's okay. But they work really, really well to do this, and here's why. You already know one of the values. It's going to be 100. So there's 4 things, and you found one of them because it's always going to be 100. The other thing that's really nice is the percentage itself is either given, which this one is, or it's missing. And so then you know where to put the X. So this one is given. It is a 25%. So I'm going to put the 25% in right now. So 25 out of 100. That's what percent means, right? It means per 100. So this 25 out of 100 means percent. So in a very real way, the left-hand side of this equation is 25%. Now the right-hand side of the equation is going to be like the discounted prices and the original price, okay? So the original price corresponds to the 100% on bottom. Does that make sense? Like it's the original amount. It's the full amount. So our $6.80 softball is on bottom, which means the part on top is the part that we don't know. You have to be really a little bit careful. The part on top here is not actually what we're going to pay. Do you know what the top of the part is? Miranda, you're nodding. What do you think it's going to be?
Is it the 680 minus whatever it is?
Yeah, so what are we going to be finding if we find the X? Do you know what it is?
The discount.
We're going to find the discount. We're finding how much we're saving. Okay, does that make sense? And why is that? Well, because it's across from 25%, and 25% was the discount. Okay, so when we get finished and we find X, we're not done. We're going to have to take that amount and subtract it off of the 680 if we go with this strategy. Okay, so let's cross multiply. Grab a calculator if you'd like. We have 25 times 680. I do not have this one written down, so if somebody wouldn't mind to give me that value, I'd appreciate it. Is it 170? Okay, great. And then the other side would be 100x. We'll divide by 100. What will x be in this case? Yeah, 1.7 or $1.70, right? And that means then my sale price is the 680 minus the 170, which means it's what? $5.10. So this one is very natural in the setup. I have a 25, I put the 25 in. But, sort of the drawback is that at the end I have to remember to do this subtraction thing. Okay? The other option is that we could actually set it up slightly differently. It's still something over 100. It's still an x over the 680. All that's different. But instead of putting 25 on the top, which represents how much I'm not going to pay, I could put a percentage in that represents how much I am going to pay. How much of this softball am I going to pay if I'm discounting it 25%? 75%. Now, the setup, right, the thinking that went into setting this up to begin with is a little bit different than the problem sort of looked like at the outset. But the good news is that when I'm done with this cross multiplication, the answer is done. There's no subtraction necessary. So let's give this one a try. If we cross multiply this one, I actually get 510 equals 100x. And when I divide by 100, lo and behold, what do I get? The 5.10 price. Neither one's right or wrong. They're both perfectly fine. But somewhere along the way, you have to really look back and say, did I answer the question? You can do it at the beginning or you can do it at the end. But you got to do it. Okay? Let's try another one. A ski area reports that 80% of its runs are open. If there are 60 runs open, how many runs are at the ski area? Okay, let's answer the questions at the bottom of the screen first. What type of problem is this? It's not 1 because we already did 1. So is it 2 or is it 3? Somebody said it. It's 3. Yeah. This one's type number 3. It's type number 3 because we don't know how many the 100% is. That's exactly what we don't know. How many runs do they actually have on this ski resort? So we're going to write this out as a proportion again. It's always got one side over 100. You can do it on the left or the right. That doesn't matter. And what is the percent of the runs that are open? It's 80. 80 out of 100 runs are open. They don't have 100 runs, but 80% is 80 out of 100, right? Then we've got 60 runs open. Where's the 60 going to go? Across from the 80. 60 runs represent the 80%, so they're on the same sort of level, right? They're across the top. And the part that we don't know on this case is the bottom, the 100% part. Okay? So again, cross multiplying. We have 80x equals 600. 6,000, sorry. I was like, that's not quite right. There we go, 6,000. That's better. And what is 6,000 divided by 80? 75. Thank you, Violet. Yes, 75. There are 75 runs. Whoops. Okay, does that make sense? Okay. Last one for today. Mort bought his house in 2008 for $159,000. It was recently appraised for $195,000. What is the approximate percent of increase in the value of the house to the nearest percent? So the question says, what type of problem is this in the bottom? It's 2 because this is process of elimination, but why is this a problem 2? Look back at the description. Why does it fit in that category? No percent is given, right? We're asked to find the percent. So problem number 2 type, and the way I've presented it anyway, is that that's the one that means that I need to figure out what the percent is. Okay, this is again one where we have a couple of options on how we set it up. So one side's going to be over 100. We'll do that. And we have the unknown amount on top. The other side of the equation has a couple of options for how it could be set up. So somebody tell me what you would like to have and where the numbers should be. Where do the numbers go if we've got this problem to set up?
Would 195 go at the bottom?
It's a good question. Is the 195 on the bottom or is it on the top? It's actually on the top. Do you know why? It feels like it should be on the bottom. Why should it go on the top?
Because you guys know what percent it needs to get higher.
Not quite. Was it 159?
Is it because that's what it changed to?
Yeah, it's because that's the new price. So the original price, just like with our sales, right? Our sales, the price of the product goes down. In this case, the price of the house is going up. But it's the original price that's still the 100% price. The price he bought it for is still 100%, so that's the 159. It's the new price, whether it's up or down, that goes on top. Okay? So this is the most natural setup in terms of solving this problem. Okay? And I don't mean like let's flip them upside down. That's not going to be a setup at all. But there is another setup that we'll take a look at. But let's try this one and see what happens. Okay, so let's actually cross multiply. I have 159,000. Actually, you know what? Are you guys okay with me crossing out some zeros so that we can deal with some smaller? Like, are you good with this? You can only do this with zeros, right? Don't go doing this other numbers. I've had students try that for me before. That's not going to work. The zeros are the only ones that work. You'll just keep our numbers just a little bit smaller. If this bothers you, keep your numbers long and it'll be fine, okay? Your calculator can handle it just fine. 159x if I cross multiply without those zeros. And then I have 195 and then a couple of zeros times my 100, so 19,500. We'll divide by the 159. And what do we get? Yeah, and let me actually write it out the way you just said. 122, what was it? Okay. All right, so 122.64. This is a percent because it's the number over the 100, right? So this is percent. Does it exactly answer the question that was asked, though? There is something still need to do to answer the question that was asked. What might it be? What do you think? We do need to round. That's something, but there's something else too.
It just wants to know how much it increased.
It just wants to know how much it increased. Did it increase 123%? No, because to increase 100% means that it would double in price, right? Like if your salary, whatever you make, let's say you make $15 an hour, increases 100%, it means you make $30 an hour. This did not go up 100%, right? What percent did it go up? 23%. So what we actually have to do then is to subtract the 100% of the original price. So our increase, I'll write it over here, is, and I'll go ahead and do the rounding now, it's 23%. The increase is 23%. And this is a pretty good way of doing this problem, but again, you still need to remember at the end to answer the question that was asked. So the answer is not 123%. The answer is 23%. So let me show you the less natural way of setting it up that gives you the answer right away, kind of like our softball question. We want to know what the, there we go. The percent was out of 100. The original price of the house, 159,000. But what we really want to know is not what the new percentage is, but what the increase is. If it was worth 159,000 and now it's worth 195,000, what is the increase in the value? So what happens if you look at just the increase in the value? How much did the house go up in value?
You have to do 195,000.
Yep, 195,000. minus 159,000. This is the increase that it had. And what is this? 36,000. So the value actually went up 36,000 in price. That's its actual value of increase. And then we can cross multiply. I'm going to cross out those 3 zeros again to make it just a little bit simpler to write. I have 159x equals 3,600. And if I divide, I'm actually going to get that same number I got before without the 100%. I'm going to get 22.64. And when it rounds, because the directions told us to, that's a 23% increase in price. Okay, we'll pause there for today.